over you like too much, you take it every day. Suppose this is like percentage like this, 80 like 80 of your time, 6 like you say half half. Think of this one as a percent. Am I right? Or is it clear to you? Like diet coke. Okay. For the weight. So the more someone might say, okay, as you take like you consume high like more diet coke, your weight goes up. So he might say, oh, diet coke is not good for your health. You have seen this one. Oh, sugar might be causing like increasing weight. This is observational. There are many things, interactions in human bodies. So it should be like you have to consider other things. You see my point? You do not look from one side. You have to look at the other sides as well. Is it clear? So this is observational data. You have seen this one in smoking, and but smoking is bad. Yeah, we know this. Do not convince ourselves by wrong. You see my point? But keep it in mind. If you would like to do something, you could do it this way. You could show some statistics, and someone might write a program saying, "Okay, I will predict the weight based on this attribute." You see my point? Or he could explain something like this, just to justify his own. If the Diet Coke or Coca-Cola company gives you money, now you reverse. You see my point? So if you would like to promote or market for them, you have to show using graph like this. Oh, the weight doesn't increase. You could show contradiction. For example, you could show um, when you eat rice, your weight increase more than when you consume Diet Coke. You see my point? So this is good way to justify, just to justify. But it is not. You cannot say this is like 100% right because it is not experimental data. If you would like to get experimental data, that is like people will make it as a foundation. You see my point? You change because in experiment you control the parameters. You see the effect of the variable and so on. Okay. For attributes, you will see two different types: categorical and numeric, also called quantitative. Numeric, quantitative. Be careful. So categorical attributes represent distinct categories rather than numbers. Okay. So it is about the category. Numbers are not meaningful here. Okay. So why? Because if you do mathematical operations, like for example, if you encode your name one, the other one, like 2, 3, 4, 5. If you do mathematical operations, it has no meaning. You see my point? Like addition, subtraction, it doesn't make sense. Look at eye color, letter grade, IP address, zip code, and so on. For quantitative, you could do such mathematical operations. Look at weight, failure per hour, number of TVs, temperature. You know my point? For temperature, you could convert it to another like measurement, Celsius, Fahrenheit, number of TVs. You would like to use it with other attribute to include another attribute, new one. You define it based on these. You see my point? So, but for those categorical, you could map it, but you can do nothing then with it. Unless if you talk about ordering, we will explain it now. So for categorical, they are either nominal or ordinal. Nominal meaning what? Like names. Ahmad, Khalid, just to distinguish. Like Ahmad is not equal to Khalid. Okay. Ordinal, the order of the attribute has meaning. You could say, oh, large is greater than medium. Medium is greater than small. If you could use these values in this attribute to make a meaningful order, good. Yes, because you have A, B, you were right. A is greater than, good. Yes. Once you make this comparison, greater than or equal, that's it. Keep it in mind. Meaningful order. Like for rating, 10 is greater than 9. You see my point? 9 is less than 10. But for nominal is like names. Look at this one. For quantitative or numeric, it could be interval or ratio. For interval, you have like differences. Like, remember money. Like, for example, some person has 100, the other one has 101 real. So you think of this one as an interval. Like the difference between them is what? 1. So you could do subtract or addition, subtraction or addition. While for ratio, you could do everything equal, not equal, greater than. In addition to the previous, you could do multiplication and division. Like, um, suppose for money, you would like to define it in this way. His salary is double that person by 100 times. You see my point? So now you are talking about division, multiplication and division. That is ratio. Okay? Now we go. So for nominal, we do not care but for distinctness. Like those are different. Like ID number, eye color, zip code. Be careful of the zip code. If you could use the zip code to order something, then you move it here. Like you order the western region, the east. You see my point? Now you have to move it. Otherwise, it is like keep it as a string. Ordinal rankings. You see, like reviews on Amazon and so on. Grades, as what you said. Height, tall is greater than me. You see my point? There is a meaning for the order, greater than or equal to. Interval, calendar dates, like for 2020. What is the difference between 2020 and 2019? Well, you say 1 year. You see my point? Temperature, and so on. GRE. Look at ratio. Suppose you would like to make ratio for calendar dates. Have you seen someone saying like this year is like by? You could do it. You could encode it, but look at the meaning. Now we are like in the difference between. Is it better to say the difference between like we were like 1 year? We are 1 year after 2019, or you could say like to make it ratio like by multiple or like division operation. It is hard. You see my point? So there is something called Kelvin. This is like by multiplication something length. Like you say, oh, the length is like 2 times something, and so on. So if you go to Wikipedia, you will see the answer. Celsius and Fahrenheit. Like suppose the temperature today is like 38. Yesterday was 39. So you could say the difference by 1 for Celsius and Fahrenheit. For that one, let me one moment, please. I will give you example for the other one. It is formatted differently. See my point? It depends on the format. Temperature example. Okay, let me give. I would like to show. Okay, let me show for this one. If you, I would like to go to Wikipedia. One moment, please. Okay, so right now, okay, so there is no like something. Have you found? I think this one. Am I right? I'm not familiar with it, but look, something like this. Like it is something like I'm not familiar with it, but this one is extreme case. You see, my point is different from those. This is the point. We use like Celsius and Fahrenheit. You see my point? For that one is like, yeah, keep the. This is like extreme example, but to show you that you could use the ratio. Look, because you have decimal points, 0.15. If you do subtraction, it is hard for you. You see my point? So ratio, we go here. Nominal, it is like IDs. A, B, C, not this one, to avoid confusion. Ahmad, Khalid, you see my point? Ordinal attributes, you care about the order. Greater than or equal to. Addition, for interval. Also, you have distinctness, for sure. Ratio, you have all these. You distinguish this by multiplication and division. By the way, for this one, any numbers like you could make divisions. Yeah, so these are like, we will go over examples to explain it more. So for we have like discrete attributes, including binary, and we have continuous attributes. So example for discrete attributes like 1, 2, 3, 4, or you have like a set of words in a collection of documents. You see my point? Discrete. Binary, we know this one. Red, green, um, 0, 1, and so on. If you would like to represent this one as integer, you make 0, 1, 1, 2. You see my point? Keep it in mind. Continuous attributes, 12.1, 12, 100, 0.5. You see my point? Like temperature, height, weight, and so on. Okay, so for categorical attributes, it is always discrete. Keep it in mind. Quantitative, it could be both discrete or continuous. Okay, look at this one. Classify the following attributes as binary, discrete, continuous. Okay, then classify them as either qualitative or quantitative. If you say qualitative, then go further. Is it nominal or ordinal? For quantitative, is it integral or ratio? Okay, we will go. So suppose we have this one. Number of telephones in your house. What do you think of this one? Number of telephones in your house. First, we would like to say, is it binary? No. Is it discrete? Yes. You could make it continuous, but for we would like to be precise. Okay, it is discrete. Is it qualitative or quantitative? It's what? quantitative? Is it ratio or interval? Like difference, number of telephones. Like, um, could we say that? Yeah, yes, interval, because you care about the difference. How many telephones do I have? How many? The difference between you and me. I have like five. It doesn't matter to say I have like 2 point something more than you. It is awkward. You see my point? So it is interval. Good. Go good. So here, okay. So it is encoded as ratio. No problem. Ratio, think of this one as integer and double. Okay? But it depends on you on the context. So suppose it is okay. I could make it like, I could modify it then. So go here. So number of telephones in your house. So suppose you would like, suppose I make it ratio. Do you think for the company they would benefit from saying, if you would like to make a database, like for someone to make reasoning to use it, this guy has 2 times of cell phones than this guy. Okay, he wants this interpretation. Okay, so we say it is ratio. I would like to show you why this one is ratio. Okay, you see my point? Okay, if it is interval, you do not care about these questions. Like, you care only about, I have like two more, like the difference. You see my point? But there for ratio, you say I have more than you by 50, by I have W, like I have 5 times than you. You see my point? Keep your mind by multiplication, division, and everything. And for interval, you will care about the difference, plus or minus, if you would like to do such operations. Okay? Okay. Size of French fries. Is it binary, discrete, or continuous? Yes, good. Discrete. Good. You could make it continuous. And continuous is like double, you see, but we would like to be precise. Okay. Depending on the context. Okay. This one is discrete. Discrete. Why is discrete? We will explain now. If it were quantitative, we have no problem to say continuous. But because it is qualitative, we know it should be always what? Discrete. You are right. So is it nominal or ordinal? Do you think that you will use this information? Good, yeah, we care about the order. You were right. Why? Because then you might map this one to 3, 2, 1. 3 has a meaning in your mind. It's big to do comparison. You see my point? It's bigger. Okay, you got the point? Okay, good. So it depends on the context. So yes, we said discrete, qualitative, ordinal. Okay. Ownership of a cell phone. Like, do you own this cell phone or not? First, this one is binary or discrete or yes, good. You got the point. Good, good, good. Classify them as qualitative or quantitative. This one is what? So you are encoding this one as 0, 1. Okay. For 0, 1. Okay. This one is a special case of discrete. Okay. So you are saying what? Qualitative. Okay. So you are treating this one as yes, no. I see your point. Okay. We will go with your assumption. Okay. Good point. I forgot this one. Do we care about the order? Yes. Yeah. Because order doesn't make any sense. No benefit. When you map it to, because for computers, for some algorithms, if you would like to map it, you map it like you do not care about the order. If you care, you have to do different mappings. You care. Number of local phone calls you made in a month. Okay. Remember this one. Is it binary, discrete, continuous? We say discrete. Am I right? Yeah, because continuous is waste like of the space. Good. Is it qualitative or quantitative? We know for sure this is what? Quantitative. Now we go. Is it interval or ratio? It doesn't. It depends on you. If you care about the difference, you could say, okay, I made like 4. The difference is 4. Yes, good point. If you care about like I have like more 5 times number of calls than you. Good point. So in that case, you make it ratio. You got the point. Good. It depends on you. What would you like to do with the data? You see my point? Length of longest phone calls. You see it on your cell phone when you talk every day with your friend. First, is it discrete or continuous or binary? Yes, yes, you need this one. Why? Because when you process the data, you would like to take care of this one. Like for STC, if you make it discrete for STC, they might lose money. For these like fractions, you see my point? They will definitely do not like your own solution. So yeah, keep it in your mind. Good. Classify them as qualitative or quantitative. For sure, we know continuous. You are right. It is quantitative. It cannot be qualitative. Is it interval or ratio? Once you see fractions like this and those like operations, this reminds us of what? Ratio. Yes, good, good, good. Length of your feet or your foot. Oh, this one we know. Binary or discrete or continuous? It is continuous. Okay. Once it is continuous, I skip qualitative or categorical. I go to quantitative. Then I go to ratio. You see my point? Good. Why? Keep it in your mind. Like, how could I say? Ratio as double. Like, for example, 13, if you convert it, you might get fractions. Do you agree? Like Kelvin or something that we have seen. We have addition and subtraction. We do not see this on interval. You see my point? Because we do division. You have this like this. You see my point? For interval, we care about differences, like 100 to 90, and so on. Yes, good. Good. Price of your textbook. Suppose if you go making the data for you make the requirements for the data when you collect it. So this one is binary, discrete, or continuous. That's good. Once it is continuous, I go here. It is ratio as well. That's it. Quantitative ratio. Now I go to this one. Zip code. Do we care? If you care about the ordering, now you order. If you do not care, you consider the zip codes are just names. This is category and specifically nominal. Also, you use what? Discrete. 1, 2, 3, 4 zip codes for someone else. 5, 3. Yes, like this. If you make it like continuous, and by mistake someone writes 1 point, it will be a disaster. You see my point? Especially if you have ordering, it will be something. You know my point. So be careful. Yeah, this one we said if you care about searching something east, west, something based on like some digits in the zip code, now it is ordinal. You see my point? You cluster people, you gather them in one cluster, the other people in other cluster, if you treat it as ordinal. Temperature, we have seen this one. It is continuous, 37 point. Then quantitative ratio. This one is true. For interval, I could make it what? I will fix this one. Yes. Better. Yeah. Oh, one moment. One moment. We said to avoid confusion. Do we have 37 point something for this now for Celsius and Fahrenheit? You could make it ratio, but it is be careful. You do not need to do so. This one is like it should be interval because you say the difference between 2 degrees is like 17. You see my point? So it is what? We will treat it as what? Interval for this moment. Yeah, make it interval. The difference between like yesterday and today's temperature, you say by 5 degrees. You know my point? You cannot say 5 point. This one is awkward. Okay? Yeah, we make it interval because it is awkward to say, yeah, this one that it doesn't. Yeah, you like for example, yesterday was 30, today is 31. You cannot say. It is better to say that it was like 1 more degree higher than yesterday. If you say by percent or multiplication, it is awkward. Like point, it is like point I don't know times yesterday more. No one says this in our life. Am I right? So we keep it interval. That's it. Okay. Yeah, because you would like to make it easier. The way to for data interpretation. Because at the end, if you report something, you would like to make it easier. Okay. We have different types of data sets. I'm not sure if it is more, but let us talk about this. We have records as what we have seen: data metrics, document data, transaction data. So if you work with a company like banking or something, they have transaction data set. You have to do some algorithms to help them. For example, finding the frequent transaction, for example, so people will focus on the bank on these like need like withdraw or like deposit. You know my point? So they help customers as what they look for. You help them. Document data. So if you have a document classification problem, you go to the people asking them what is your objective and so on. Data metrics and for a problem like for a fraud in the bank, whatever. We are talking about the types of data sets. In graph, you see the web. It is represented as a graph. The order like spatial data, temporal, sequential. We will have examples here. There are characteristics about the data. Keep these concepts in mind. I have made this one in my research. Dimensionality. Once I say dimensionality, meaning what? Number of features or attributes. Okay? Do you have 4 columns, 6 columns? You see my point? The issue is that some algorithms, if you have million of columns, they do not work well. So high dimensional data have like or bring some problems for some algorithms. We will talk about k nearest neighbor as one of them. Sparsity. You will have a data matrix. Most of the attributes for each object have zero values. Fewer have like fewer counts, like 1, 2. But for sparsity, always we have zero ones. Ones are few, or sorry, to be precise, we have fewer non-zero values. Okay. For zero values, you have a lot, maybe 99% something. It is called sparse data. Okay? Resolution or الدقة بالعربي. Okay, so this is like about when you record about the patterns or the exact objects at different like occasions, it might be different. It is like scaling. Think of this one as when you scale the resolution of the picture for the same picture. You see my point? Clear to not clear, like this one. You have to be careful of this. The size. This is one of the big data issue. Specifically, if you have 10 million or 100 million records, so the data size is like, suppose the size of the data is like 100 giga or something. Also for this one, I have worked on this one. If you have 100,000 features or attributes, the algorithm will get confused. Also, it will be slow. So big data nowadays are talking about big data like the size of the data set on your disk, more than 100 gig or something like this. In the past, before maybe 10 years or something, depending on the technology. So you define big data. It might be like 1 mega or something was big data before like 30 years. You see my point? Depending on like the technology as well. But once I say the size, it depends. You have to be precise. Those are issues. Come with the data itself. Now, if you have a record data, look, you have 10 objects or records or 10 people. Think of this one as information about 10 people in terms of the tax. So this is about to find whom it cheats, like if you pay the exact amount or not. You would like to do a program, for example, to مصلحة الزكاة والدخل. واضح؟ جو طلبوا منك برنامج عشان تشوف تقدر تسوي لهم نفس الفكرة وتحل لهم وتشوف من الشخص. ليش؟ Why? Saudi Arabia is big. You have how many companies and you have more than you have like the file, if you store it based on this information or more, it will be more than 100 gig or so. Human being cannot find this easily, so you have to help them. It might be like more than like 10 million or like 100 million records. So as a human being, I cannot trace this. You see my point? Or track. So you have to help them using machine learning or data mining technique or whatever. You see my point? You might be doing like some simple processing, taking some features from here. You could say to them, okay, now I do some machine learning to predict is it a cheat or not. Okay? Okay, we go next. Data matrix. Look at this matrix. M by N. M is the number of rows. How many rows do we have? 2. How many columns do we have? 5. Okay? Okay. Document data. If you do for some people document classification, that you might have something like this. So look, for each document, this is like one object, one human being, in other words. But now we are talking about documents. You see my point? The number of teams, the number of coach. Someone gives you this data, okay? He collects the data, gives you. He might ask you about something. Okay. Transaction data. We will see this one in association rule mining. This one is, I'm not sure, but in the US they use it in Walmart. Here I am so sure they use it in Danube and Panda. I think in Panda have it. I think so. You see some offers, like for example, they make like discounts for Pampers or something. Am I right? Why? Because he already knows from what you purchase. If you buy this one, you are most likely to buy milk and other things. So he increased the price for other things without your knowing. He might add 50 halala or something. You see my point? For me, for myself, when I go for specific things and they go out. But sometimes because of this situation like COVID, I do not care about this. So, but you know my point. I know someone whom is clever, whom purchasing like cell phones. He's smart. So, if you make discounts, make sure that they are thinking about others. That you are. But honestly, let us face it. So, when you go to the supermarket, if you buy the discounted one, most likely you will buy other things. So he will substitute his loss. You might be thinking, oh, here is a chip in Danube. Here is in Ban. You know my point? Keep in your mind this one. We will talk about this one. You will like it. It is called the technique that solves or find these like uh, association is called association rule mining. Okay, I have worked on this one. So suppose I have numbers like um, suppose this one. This gene regulates this one. Okay, for example. So I have this graph, or you have this molecule, or you have someone using web pages with names, but he says this one refers to this one and that one refers to that one. So when you encode it, you make the data set. You have to do it, for example, suppose as a data matrix. You will use numbers. Be careful when you have the data set. Okay, how to represent the data. Okay, it is all about data representation, because computer cannot process this one. Am I right? If you would like to say, uh, I would like to rank pages. So if you give like links, computer doesn't know about this. So we have to give it to the same format to the computer for the specific. Yes. So you have to make it like, how could I say? Um, you have to give it like, if the algorithm takes data matrix, you have to give the computer data matrix. That's it. Compatibility with the same format, data format. That's it. So even for me, in gene regulatory networks, yes, you are right. It is all about data structure. Good, you are right. So at the end, if you give the computer, suppose he accepts numbers, you have to make data matrix, numeric, for example. But those, you understand the data set. You see my point? You have objective. Oh, if you see numbers, you know what is the meaning of this one. Okay? Yeah, so keep it in mind. For me, I take this one, I encode it. So if gene 1 regulate gene 2, I say the label. This is the outcome. I make it as 1. Otherwise, 0. If this one has no edge like this, I make it 0. Okay? So keep it in mind. And I have all features for the gene. I do concatenation. I take one expression level. If you are interested, I could explain it to you with this one. Now I represented this link. So it is a link prediction problem. I would like to predict if this one regulates that one or not. You see my point? You are working with the data. You represent the data before you give it to machine learning algorithm. For deep learning, they would like to skip this one, the data representation. They would like, oh, okay, I have a graph. I would like the algorithm to find good representation and to do the classification at the same time. You see my point? Here now, that deep learning comes out. Hopefully, the difference is clear. Is it clear? In other words, for machine learning, you have feature engineering coming from expert. If you are working in Aramco or something, you have experts there. You go to them asking about the data collection. But if you have no experts, you have to come up with algorithm to find the data and to do the task. That is the main goal from deep learning. Is it clear? They would like to replace people. Keep it in mind. That's it. So, but for machine learning, if you if you have like experts, you will come up with results easily. Also, if you have experts, you might beat deep learning, but deep learning might beat as well. So, yeah, it depends on the algorithm. If you are saying, you are claiming, oh, I am 100%, or sorry, no one could come up. I am 99%, 95. People will look at you. If the problem is complex, like the stock market or the Saudi stock market, if you have a program looking into the picture, taking, processing something like this, giving the answer, this stock will go up, that will go down. All people will subscribe into your own software, so you will be rich. Okay, we go next. Sequence of transactions. You could have data like this one, but you have to encode it as a data matrix. That you might use deep learning, something like this fancy. If you use machine learning, you have to encode it. A, B, I map it. For that reason, we talked about qualitative, categorical. You saw the headache? So, yeah, so data representation because is important. You would like to make meaning. We go next. This one, sequence data. People use this one to extract features. So, if you have other objective in genomics, like to predict something like this drug is sensitive or something, you have these, you could incorporate these using deep learning. Deep learning might use extract other features from this one without the need for biological expert. So we go next. Look at this one, spatial temporal data. Look, this one from month to month, it change. So this one is a problematic data. You have to take care of it. It has time and it change from time to time as well. Um, the MINIST dataset, this dataset is like in image processing or computer vision. The task is that you are given a training set, images, and the corresponding label. This image is 0, that one is 1, that one is 2. Your task for a new image or a test image, you would like to predict, is it 0 or 1 or 2 or 3, 4, 5, 6, 7, 8, 9? Okay? So, deep learning, it takes the numbers, it trains. Look here, we have images. We have no features extracted. Am I right? You give it to deep learning, you get model or trained deep learning. For new image, you give it to the trained model, then you predict. This one is 0 or 1. This one is called hello world in computer vision. If you do any research in computer vision, you have to apply or test your algorithm on this MINIST dataset. Okay? Okay. For the Netflix, they offered like $1 million if you do solve their own issue. So look, you have a data set for million or big number of users, and you have movies. Columns are movies, rows are for users. Okay, so the ranking for this movie for user one, Ahmed. Suppose the movie is A, its name is A, it is 1. For other movie he is 5. Suppose he has missing missing. Netflix wanted you to predict these missing rankings. Why? If you predict these correctly, they will be rich. They know which movie you like, so they would like you to stay, to not go out of the subscription. You see my point? They will get billions because they have many people. So they said, okay, we will give you $1 million. The AI researcher might think, oh, for us, we think, oh, this is like tempting. Am I right? You would like to do it. So they have hidden. So because actually to test, they do not have, they have many missing values. Okay, we agree. But for many or some, they have available ranking. So they hide it from you as an AI researcher. They have the ground truth, the actual ranking. So they say, okay, here is the data, take it. Those are missing. Predict this for me. You see my point? For you, you try to predict, and once you predict, they evaluate. They take the best one. Suppose they give you $1 million. It goes over competition or a challenge to improve their own. They know that you scored very well on the training. So for them, they will take their your own algorithm. They will apply it for their own missing values. Is it clear? So look at the business, how it goes for Netflix. Yeah, they are smart. So this is the way. Even you see some people making games on the internet, something. Be careful. This guy tries to collect some information from you. This will be beneficial for Google or others. So he might sell the data. You see my point? For other companies, something like this. He will be rich in other way. Why this is important? He knows about you. So for ads, advertising for Google or others, they might use it. Some people will be interesting in these data. And you might be thinking it is just clicks. No, it is not about clicks. It has something behind it. Okay. So for in unsupervised learning, now I would like to explain something to you to keep it in mind. Now AI is changing. I'm working with a Japanese professor. So we have seen data like objects on rows. Am I right? And features on columns. Am I right? Now think of this one. This one actually it is a 2D matrix. Am I right? Now people are working on tensors. You do not have two axes because suppose I have 10 examples. This y-axis has 10 examples. This x-axis has suppose 5. Now you have x-axis, y-axis, z. Each has like different dimensions. Dimensions like the numbers that are there. Like suppose you have 10 rows, the dimension here is 10. If you have 5 on the x-axis, the dimension is 5. Now we do research like for simplicity. X, Y, Z, W, each one has like different data. You see, the different dimensions, information, additional. So you cannot represent this one as a data matrix. So there is something called tensor learning. You see my point? I am so sure Netflix will like to see. It might improve their own. You know my point? So someone, if you would like to be clever, you could propose this one to them. Oh, I have a recommender system. Look, I am beating you. I am beating 2D. You see my point? I am beating better than your TD, that your TD algorithm designed by some people. You see my point? You could beat them. Tensor learning was before, but now because data are complex, you have to come up with new algorithms. So this brings new challenge. If you show that, oh, I am having complex data, I am beating this regular data matrix, you will be rich, inshallah. So now we go back. As we see, we have objects here on rows, variables, factors, features, attributes on the columns. You have different names. I use it features, genes, the same. All are the same, referring to the attributes. In unsupervised learning, you do not have the answer. Suppose you would like to know whom it cheats or not for taxes. Yes, good label. Good, we are coming. So you have variables like quantitative, weight, height, whatever you have, or qualitative, college, profession, AI researcher, whatever, for the values. You see my point? So, given this to you, your goal is to find meaningful relationships between variables. This is called correlation analysis. Or you would like to group the data by clustering. Why you group? Suppose you know you have people that cheat or not. You would like to do unsupervised learning. It is very fast because there is no learning. We will explain why it is fast. And you cluster those who cheat and those who do not cheat. You compare to the ground truth. Oh, you beat the supervised learning. People like your own solution. Unsupervised learning is the future. Even deep learning, they focus now on unsupervised learning. Even my friend and I, we are doing tensor learning in unsupervised learning. Okay, keep it in mind. This is the unsupervised, the supervised setting. You have the output label, and you have the data given here. Okay, if this one is a quantitative continuous, specifically like the stock market, 10.5, 10.1. You see my point? You treat this one as a regression. We will talk about linear regression because you would like to predict continuous value. If this one, the outcome, like a cheat, yes, no, like this is a classification problem, okay? If yes, no, we say binary classification problem. If 0, 1, 2, 3, 4, there is no or mean for the order, but just we are using labels. You see my point? For 0, you might say a cheat. For 1, not a cheat. For 2, you might interpret this one as may, not sure. This is called multi-class classification. So you have binary 0, 1. Otherwise, multi-class. So you have two schools. Once you have supervised learning, parametric, like logistic regression. Look, you have to learn these. Once you have a training data, you would like to find the best parameters in terms of like reducing that you have to reduce the training error. Why? Because for a new test example, when you apply this test example, those learned parameters from the training, they are fixed. We say fit, meaning what? You would like to find these parameters from the training. For new example, you will include it, you multiply, and you add, you get the number. Non-parametric, we do not make assumption. Look here, we are making assumption about the shape or the form of the algorithm. Am I right? But for like decision tree or something or others, it might be non-parametric, like k-nearest neighbor. You know my point? Why I say for others like non-parametric? I could have some simple calculations, input, output, function because input, output. I give you example, new example, you predict. Okay, function, map. So for R, categorical represented as factor, otherwise numeric. So for classification, you have to make it factor if it is yes, no. Regression, be careful, numeric. You have to check before you give the algorithm. This is to set your working directory in R. If you would like to know where is my directory that R reads from, get working directory. Read N. Suppose you have a data set named data.txt. You separate the columns by this, like there is a like single spacing, okay? Header equals f or false, meaning what? The data has no names for features like color, something, because you have actual numbers for your data you would like to process. If the data that you read from has the first row including names of columns like name, ID, zip code, you have to make it true. You have to tell R, be careful, skip this one. Okay? Okay. Now suppose you would like to read the first column. Look here in R, it says levels, 670 something levels. If you check this column, is that factor? Yes. So this one is categorical. If you would like to do additions, you cannot do this one because it is category. We know this. Also in Excel, you are expert in Excel. I am so sure. You could do some formatting like number, currency, accounting. You are changing the formatting. You see my point? Okay. Let me know if you have any question. Hopefully today is fine. Is it fine? Good. Yeah, inshallah, when we go, we will do coding even in the lab. Try to download R, play with it. Look at those references that I posted. Check the URLs. I think they are working. Am I right? For references for books, I made the URL to like direct you to the source. So let me. I will double check them as well. For this one, honestly, I didn't like for one fact. If I record, you will not come. Believe me, because of the timing. Someday, someone coming to you like this, you would like to go out. I tried this one, so I highly recommend to come. If you do not understand something, please me to the blackboard. In that case, I explain it. Then I know that you understand. If you do not understand, repeat, send it again. I would like to make sure that you understand. I do not want you to just collect textbooks. No, I would like you to understand, to get like 90% of the course, 80. When you go after graduation, you will remember me, inshallah. I would like you to to be like the best, inshallah. This is the human nature. Believe me, if you buy textbooks, you buy, most likely you will not read. We are human beings. We like to be concise, fast. Like, give me this one. I do not want to spend much time. I would like to go to mosque, to do activities, to see like my family. We are human beings, honestly. Also, I would like to study this. So I would like to make it. For me, I am focusing to make the slides having everything that I could put in. I would like you to like have everything on the slides, inshallah. If something else needs to be considered, I will send links on blackboards like this for exercises and so on. بالتوفيق وان شاء الله حاولوا نزلوا الار ان شاء الله في اللاب. حارس الرابط ان شاء الله نفسه عن طريق نفس الاسلوب، فين مكانه في البلاك بورد نصير ندخل ان شاء الله نشغل الار ونتاكد كل واحد شغال، كل واحد فاهم ايش البيانات اللي بتقراها. You understand everything. اللي يخلي الاي اي or what makes اللي يخلي الاي اي صعب نظري وعملي في نفس الوقت، ومتطلبات شغلات ثانيه. يبغى لك تفهم الخوارزم وتنفذه وتعدي، وان كان في تعديل، ويعني يعني شغله باليد صراحه، شغله باليد. يعني زي ما تقول ايش، تشوف الشيء قدامك. هذه حاولوا انكم تتفقوا على وقت محدد، عشان ما نبغى اروح في وقت معين وزميل لكم متعارض مع الوقت، فهذه يعني ظلم له. فوضحت الصوره. حاولوا انكم يعني تتفقوا كلكم 15، وابشر ان شاء الله عادي. ما هي نفسها رابط نرسلها ونتابع مع بعض، ما فرقت اصلا. اهم شيء انه احد لا ينظلم. عشان ليش؟ لا واحد ننسى زميل لنا ولا شيء فيأثر عليه. يوم اللاب ان شاء الله نتفق على وقت معين. حاولوا انكم تكونوا جاهزين. اتفقوا مع بعض ان شاء الله. ان شاء الله نشوف في اللاب اللي جاي نتفق على الوقت ان شاء الله. نسأل سؤال في الشات وكلكم متفقين، يصير نعدل الوقت ان شاء الله. حاولوا انكم تشوفوا السلايدز. اتدرب على الار عشان الكلاس اللي جاي ان شاء الله، حتى لما ندخل يصير ايش. واحاول ان شاء الله اشوف السلايدز قبل الكلاس، يعني اسوي لها تحميل. والماده زي ما انتم شايفين ان شاء الله، بس يبغى لها ايش، متابعه وحتكون مفيده ان شاء الله، من المواد اللي ما حتنساها ان شاء الله لما تتخرج. بالتوفيق وفي امان الله. الله يوفقكم. في امان الله.